So good afternoon, everybody. Welcome to the award ceremony for the Helix Nebula Science Cloud Pre-Commercial Procurement Project. This afternoon, you will see a series of brief interventions by the hosts of the event, the people involved in organising this innovative pre-commercial procurement, and of course the contractors who have won work orders to go through to the final pilot phase of this process. Okay. We'd start by handing over to our hosts from INFN. Okay.
Hi everybody, my name is Luca Daniello, and I'm not director of CNAF. Unfortunately, Gaetano, the director of CNAF, is currently busy. He will join us later on. So I will give a very brief introduction to INFN and CNAF and the importance for us of joining this project. If you are very interested in knowing what we do here at CNAF, I leave you some USB with keys with our last annual report. Okay, INFN is the National Institute for Research in Nuclear Physics as a government entity. The main mission is the research and the study of elementary particles and physics laws of the universe. It is composed by several units which mainly are devoted to research in physics, of course. The only one which is instrumental to this in computing is CNAF, where you are now. And CNAF is one of the 3 national centers dedicated to specific tasks. The only one dedicated to computing is this one. The INFN computing infrastructure is quite large. It's composed by several computing centers, the main one being here, but there are also 9 tier 2s for WCG distributed over Italy, and there are several other smaller centers, over 30 centers in all over Italy, managed by INFN people. But obviously the INFN and CNAF is not only involved in computing for managing the resources for the experiments, but we also participate in several projects for development, study of computing, mainly in the distributed computing like grid in the past, the cloud now. And besides Helix Nebula and Science Cloud, we, as you probably know, we have been deeply involved in Indigo Data Cloud. We are involved in EOS Hub, Stream Data Cloud, DeepIP, and several others. The importance of this project, my kids, sorry. The importance of these projects for us is crucial because these projects should help us to define and drive the development and the evolution of our computing infrastructure, obviously together with the other funding agencies, at least all over Europe, to cope with the requirements of the high luminosity LSC, but also for other future generation experiments that were missing, like CTA, SKA, and so on. I guess this is a common problem to all of us. But CNAF is this present incarnation of CNAF devoted to scientific computing is quite recent. We started to work on scientific computing only at the beginning of 2000 here, while in the past we were dedicated to other tasks. When I joined CNAF in 1996, we were fully devoted to the development and the startup of our national research network, GAR. And before that, other tasks were our mission. Nowadays, The main focus is on supporting scientific computing over experimental theoretical INFN groups, which you can simplify saying we manage the tier 1. Then there are innovation development activities, mainly on distributed systems, but not limited to that, because also we're studying new we are part of projects studying new technologies, like for processor storage system and so on. And then we have also, obviously, an activity for technology transfer, which is as important as the previous two. Sorry. Oh. If we started our activity in scientific computing at the beginning of the century, joining the project of data grid and data cloud, if I remember correctly the name. Our first prototype for the tier 1 dates back to 2003, and we started supporting the last generation experiments like Babar and CDF, and starting to test with the LSC experiments. Well, then, as all other tier 1s, we have evolved in the present situation, and nowadays we provide services and resources to more than 30 scientific collaborations founded by INFN. Well, here there are some figures, but okay, these are not that important. As you for sure know, last November we had a severe flood in the data center, and we are just recovering now from that situation. We have been out of business for more than 2 months, and now to give a preview for the next week GDB talk for Ian, we have recovered most the farm, the tape library, and we are recovering the storage. Apparently, no data loss. This is an important thing, but we are still to finish the work. I want to mention here some projects we were working on, and we are working on till today, which are related to the use of remote resources as provided by Helix Nebula. Last year we had in production 13% of the WSCG resources, not for the CPU resources. I mean, not here at CNAF, but quite far away in Bari, 600 kilometers from here, and they were accessible in transparent way from the experiment. Okay, at least somehow similar to CERN Wigner extension with dedicated network between the two centers. To answer in some way to the talk on WP4 this morning, we tested another technology for cache system for the transparent access to data. We have for our storage we use GPFS to manage the storage. There is a plugin for GPFS which allows to use it as a cache on a remote side. I know that the third concurrent in the 10 IBM retired was obviously proposing that. So somehow we have some sort of comparison between the two systems. We have also done some tests of opportunistic computing on a commercial cloud provider, Italian commercial cloud provider, but very small scale, so not worth mentioning here as for the figures. And in the next months, this month, the end of this month, and for starting from production from end of February, we'll have roughly 50% of our CPU resources, not here, but in another site close to here, 30 kilometers from here, managed by Cineca, which is, as you probably know, is a part of PRAISE, is a HPC center, which leases us these resources. we are going to have a distributed center with one VPN, 500 gigabit, possibly to scaling to 1.2 terabits between us. This is almost the CPU there and the storage here are almost online because on local area network, since the round trip time is comparable to that experience on a local area network. So in this case, we will not have this cache like with the barrier extension, but it will be a direct access to CNAF storage. Obviously, we haven't had the possibility to test it because the test phase was supposed to be at the end of last year, but of course, with being out of business, we couldn't do anything with that. These are some pictures from the flood taken the same day it happened. So there were 50 centimeters of water everywhere. This is this completely ruined the electrical equipment. This has been the hardest part to recover. Then for the hardware, I mean the computer resources. Okay, you substituted that. That's no problem. For the disk part, the difficult part is to wait for the replacement components. That's the one. Incredibly, this was the hardest part. And as a summary, okay. Besides the wishing you please a pleasant pleasant staying here in Bologna, and wishing you a very good work. I personally think this is our participation to Helix Nebula is crucial. Okay, I'm sponsor. It's crucial because this helps us to understand both the technical aspect to using commercial cloud resources on a larger scale than the limited test we did on ourselves with the Italian commercial cloud provider. And then there is also the practical issue of procurement of computing power instead of computing capacity. We buy the worker nodes and put in operation. How it works with probably with a more volatile mechanism of buying when as you need to absorb the peaks and so burst computing and so on. This I think is what you hope to gain from this all of this. Okay, so have a good work and best wishes from the CNAF director, which should join us later on.
Thank you very much.
Oops, sorry.
So thanks very much, Luca. It shows the technical expertise that exists in the procurement group inside Helix Nebula, which is driving a lot of this work. Also demonstrated the advantages of a hybrid code model for use cases such as disaster recovery, which is something to think about as well for the future. Okay. We've talked about the commercial procurement. How important is this for Europe? How important is innovation procurement? And I'm pleased to say we have Dr. Dirk van Rooij from DG Connect here with us today, who's going to elaborate on some of those subjects.
Thank you. Just show me this one.
Yes, that's the one. And then you get the microphone from Luca.
Perhaps, perhaps we'll try without the microphone.
No, we can't hear you on the web if we don't.
Oh, okay, I understand. So, mic, please. So. So, good afternoon. Thank you, Mr. Chairman, for the invitation. So, I'm Dirk van Rooij. I'm the head of sector of the cloud computing domain in DG Connect of the European Commission. And I have agreed with Bob to speak about actually 3 topics, but I will be very selective on the messages. The one is on innovation procurement, and I'm not going into the definition of it. We had a session this morning. I think it deserves an entire workshop. And I will make the link to the European Open Science Cloud and the work of Helix Nebula. I will not speak a lot about that because there are other people in the room who know much more about it, can speak much better about it. And I will put it in the context of the European digital single market. So let's see if this works. Okay, why is the European Union, the European Commission interested in the procurement of innovation and for innovation? Now, we use the terminology PCP, pre-commercial procurement, and PPI, public procurement of innovation. I'm not going to explain that. I assume most of you are familiar with that or know something about it. But the reason, I want to tell a bit about the reasoning behind it. Now, there is indication that innovation is very often driven with by the public sector, at least with the involvement of the public sector. And if you look at small companies in particular, the major problem often seems to be finding the first buyer. Once you have the first buyer, it usually is much easier for them to continue. Also, financing is a problem, but often if you have a first buyer, it's also easier to settle on the financing issue. There was a book by Professor Masukato, and she did an historic analysis of innovation, and her conclusion, she argues that the public sector actually has very often been decisive in driving the initial innovation and the growth of companies. Now, I'm not saying that this is limited to the public sector, but very often there is a decisive involvement. We have been doing this PCP and PPI for some years, and we did some analysis, and what we found is that companies who have been involved in public procurement have an easier time, like 61% versus 15%, in getting follow-up contracts. Now, there may be many different reasons for that, because these companies may be inclined to be better able to sell their products and so on. But nevertheless, there is a kind of a picture. Now, it's not only about giving subsidy to the private, from the public sector to the private sector. It's also about helping the public sector itself. The public sector has a need for innovation. Public sector is not only administrations. It's like infrastructure management, education, healthcare and the like. So they have an intrinsic need also to modernize. There's another thing, by doing the PCPs and the PPI, you also enhance or widen the scope of the value chain. Now, this morning we had a discussion. Sometimes it's easier to do things by yourself, but then you have something that may be customized and limited to yourself. So there's like a trade-off to make there as well. Okay, this is the story behind it. So on the procedural details, I think other people in the room can tell about that. Oh, I did something wrong. Down, okay. Done. Okay. Now, I just quickly want to go through this. We have done an analysis of the type of organizations making use of the PCP and PPI from the provider side. Of course, there are small companies that often have an innovative idea or a product, but also larger companies. And we heard this morning as well in the PCP of HN Science Cloud, there are actually many large companies or larger companies present. So it's not one or the other, it's both. But an important observation that we have done is also, like universities or research institutes are involved in the PCP process through in a consortium or through a spin-off company. So it's also helping bringing research results into the innovative domain. And then what we see, particularly since we are working at the European level, we see a lot of cross-border kind of cooperation, which fits very well with our concept or our goal of a digital single market. So this slide, I'm not really going to explain all the details, but I'm showing it because I think some of you might be interested in getting involved in the funding scheme that we have for PCP and PPI. The most important here is actually the bottom line, which gives you a link to the current work program for the funding from 2018 to 2020. And if you look at the top, you see the figures 41 million for 2018, 83 million and 100 million. So it's actually substantial funding that we have dedicated, earmarked for this purpose. The topics itself and whatever, I would refer you to the work program. Now, so I have already made a link to the digital single market, so I want now to focus a bit on the DSM and on the cloud computing part of it. Now, the activities we are doing are part of a larger context, a larger package. All the bullets that I'm shown here are all policy documents that are related either to cloud computing or the DSM. If you want to read something, then I would recommend the third bullet, the digital single market, which is a document of 15 pages and is very comprehensive in its scope. Now, one of the areas is a European Cloud Initiative, and the European Open Science Cloud is part of that initiative. But we have others like on e-government, on the Industry 4.0, the next generation of industrial production. There's on standardization, on data economy and the like. Since the topic of today is like the HN Science Cloud and related and the PCP, so I want to speak a bit about the European Cloud Initiative within the digital single market. And the second bullet is the European Open Science Cloud. It's all in the document. As I said, I'm not going to explain that, but I want to explain something different. And it's really the bottom, widening the access and the user base. How I'm doing in time? That's okay. So then, okay, Bob says I'm doing well in time, so I'm going to ask you a question. If you look at the adoption and the uptake and the development of the internet and the World Wide Web, this is like tremendous. Very rapidly, everybody's using it. So what are the three key technologies that have enabled this success? So like 20 seconds, anything that pops up in your mind, please. Speak loudly. Networking. The three key enabling technologies for the success of the internet and the World Wide Web. The web. HTML. Okay, so thanks for your input. I think, of course, you're very close, but let me give you my view on that. I think the first one is actually the internet itself, the physical connection of computing devices with the accompanying protocols that enable the exchange, the communication between computers. Now, the origin, as you all know, I suppose, goes to defense, but it was used and taken up by universities, and from then on, it went to the rest of society. Then the second one is the hyperlink, and I think it came from CERN. It was developed within a scientific context, and it is a tremendous technology. Just by clicking, you get access to information without having to bother about how and when and where the information is located. So this made it possible to be used by anyone, basically. And the third one is in my view, the search engine. And as far as I know, the first real search engine was developed in 1990 at a university in Montreal. It's called Archie, which is kind of it derived from archive. So it was made as well within a scientific context, access to library information, indexing and the like. Now, in my view, these three technologies actually are the three technologies that explain the rapid success and uptake of the internet by like common society. What is interesting, the reason that I'm asking or telling this story and asking the question is that all came from science, or science was involved in like making it available to the rest of society. So what we now hope is that the European Open Science Cloud and the way the scientific community organizes itself, making best possible use of cloud computing resources, that can have a spillover effect to the public sector and to industry and perhaps to other areas of society. Okay, and last slide. So I've talked about the digital single market, about cloud computing, science cloud and the like, but we have of course many other areas where we apply the pre-commercial procurement and the PPI, procurement of innovation. Healthcare obviously is a very important area, it's used a lot there, but also in e-government, in industry 4.0, this is the digitalization of European industry. And we are looking at a number of of other areas of importance, like cybersecurity, that already is very important and will gain in importance. But we're also looking at like the next generation internet, artificial intelligence and green ICT, I believe, which has come to us as an additional requirement on top of all the other requirements that we already have had. Okay, I think, thank you very much for your patience. I think I went a bit over time, but I tried to be concise nevertheless. Thank you.
So Dirk talked a lot about innovation. What I'd like to do now for the next 10 minutes is explain to you a bit the innovation process that's been used inside the Helix Nebula Science Cloud pre-commercial procurement action. So the real goal was to come up with a common platform that can be used by Europe's research communities as a mechanism for addressing their growing needs associated with the increasing amounts of data coming off the research infrastructures that they host or contribute to. And by doing this, it would allow us to increase our analysis capacity and capabilities, essentially to produce more science. It's brought together the committed consortium of 10 procurers from across Europe, all listed here with their logos across 7 different countries. And each one of these procurers, as you've seen the example already from INFN, already has significant IT expertise, resources and capacity, which they're committing in to this activity, along with their own manpower, applications, data and services, which they want to integrate as part of this overall procurement process. And the idea is the resulting services, innovative services, can be made available to a wide variety of different user communities from the different research communities. And the whole process is co-funded by the European Commission under the Horizon 2020 programme. What's actually being procured? Well, for those different research communities, there's a combination of services at the infrastructure as a service level. We're staying at the lower level. We can see opportunities in the future for stepping up, higher up the structure level and going to platform as a service and software as a service. And those innovative services are being integrated with their in-house resources, the data centres, such as ones as INFN, but also with the public infrastructures, in particular the Xeon network, which links together all the research and education organisations and institutes across Europe, and the EduGain Federated Identity Management System. And this brings together to form an important infrastructure which is being used to address a number of challenges that have been outlined as the initial structure and the goals to be achieved in this procurement process. Around the area of compute and storage, support a range of different configurations of virtual machines with different and containers, including HPC and data sets into the petabyte range. Network connectivity and federated identity management provide high network capacity via the Xeon network and the NRENs bring it together to form an end-to-end system with a common identity management system. And service payment models which will be adapted so they suit the publicly funded research organisations and the end users that they sponsor across the different research communities. This together is brought together as a hybrid model, bringing together those different elements so that it represents a whole where we can make use of the most appropriate services, resources and capacity according to the job at hand. Okay. It's serving a number of different research communities and specifically takes into account the needs of the research infrastructures that have been identified by the member states and funded by the member states as part of the SV process, so the SV projects and the landmark projects. You can see them shown on this graph according to colour by discipline, and the little Helix Nebula logo show you the 7 different research infrastructures needs that have been taken into account. This is just a start. We expect that what's actually being put in place here in the innovative services can serve for a larger group of procurers, that's to say more research infrastructures, and also other research organisations not actively involved in those research infrastructures. In terms of the process, we have a number of steps. We started with the preparation phase, and we had a webinar at that stage, and then we've had a series of competitive tendering steps, starting off with 4 designs, then selecting from 4 designs down to 3 prototypes, where we implemented, the contractors implemented their designs in functioning prototypes, and now we're at the stage of selecting the 2 pilot phase contractors who will take those prototypes and scale them up to usage by a large group of selected end users from the different research communities. So without further ado here, it's now time to announce who are the contractors who have won awards for this pilot phase. And so to start, I'd like to invite the first contractor to come along and receive their award, and that is Yuri Delamar from T-Systems. There you go, Yuri. Okay. And now over to Yuri.
Thank you, Bob, for this award. For us, it's simply a pleasure to be part of Helix Nebula's Science Cloud. And if you then also start winning awards, it's even better. So let me share with you what we have experienced since the start of the project, and also give you a bit of an outlook on the phase 3 that we are going to start from T-Systems perspective. So we started, as some of you will remember, 1.5 years ago with a small team that put some first ideas to paper. And I'm very happy that basically all the faces you see here, we still have very much present in the team, and some of them being here in the room. And the team has also grown. So for the next phase, we will have about 20 people in T-Systems and our partners that will work on bringing this vision now really into the organizations to use it every day, and also, of course, what I will talk about later, for other organizations to look into it if it's interesting for them. So from this vision, we, of course, as T-Systems, needed structure to implement this, to run the project. That's done with 3 key partners. T-Systems being responsible for the overall project management, the scientific challenges, running the infrastructure as we have proposed. We have then Huawei as a key technology partner that provides us the OpenStack technology and the hardware that we use for the solutions. We have Cyfronet from Poland that provide us with a very state-of-the-art and beautiful data management solution, which I will talk a bit about later. And last but not least, we have a SME from Germany called Divya that helps us on commercialization of the results of the Helix Nebula project and business models. And that will become especially interesting in the phase 3. I also come back to that later. So I want to touch on 4 elements. One first, of course, the pilot. What are we going to do next? Then briefly, what does it mean in terms of numbers? I think in cloud computing and also in physics, everybody's always interested about the numbers. Then about this commercialization aspects, what to expect out of the Helix Nebula project that we will bring to the market, and where we see growth opportunities, and at the end, what do we see as the challenges of the phase 3 and the things that we want to find out together with the users. So first about the pilot, the solution that we provide, of course, in the core is this hybrid cloud that Bob has introduced, with the data center usually being at an organization, a private solution that is then combined with our cloud as a remote facility, surrounded by a set of functionalities and tools to create this really seamless user experience. And to highlight some of these aspects, for example, service payment, very important in science. We know that this has some very special requirements, and that is where we will introduce new service payments very much fit to this science environment, with access for then users also to enterprise agreements. Another thing that we developed as a result of the Helix Nebula project, where users also get really a service that is with a certain quality, with a SLA, as we call it, service level agreement, and other qualities in terms of support, so that they really know what they get. And this can be in different flavors, from bronze, silver to gold levels. Another element is that we know science is very diverse. Also users are very diverse. That means different access for different people. We allow access through programming tools, but also very simple web interfaces to do exactly that what people are used to in their own environments. Or to use their favorite tools to do the work in an automated way. That is, of course, what we all want to achieve at the end of the day. And to use these tools across the hybrid cloud. What we have also in the solution are new HPC functionalities. I think especially in science, we know that certain workloads really benefit from this. To do processing on HPC platform can extremely shorten times. Also important to manage large sets of data, for example. So this is embedded together with the One Data data management system, on which I will come back on the next slide. And as it was mentioned, the GL network to connect all the elements of the hybrid cloud together. And we will connect our remote cloud with in total 60 G of network capacity. So thanks to Géant that this is possible. And this the users of the Helix Nebula project will be able to use exclusively. Coming back to the data management, a key element of our solution is the One Data solution that really gives users two really new functionalities. One being the access to distribute the data wherever it is, in what type of file system or in what type of storage solution. You are able to access the data in the same way as if it would be in your own data center or in the cloud. You simply do not have to worry about this. Relates a bit to the internet hyperlink idea, that users can relate to this. And second, that it is really transparent, so that you can still do the same with the data as if it would be on your local infrastructure. And our implementation of this One Data solution within the cloud will allow two scenarios, basically. One where customers are really able to individually configure to achieve the highest possible performance on a certain infrastructure. And we also will provide a pre-configured service that will be simply usable by a login, by creating an account, and then start uploading data, sharing data, and giving people access to that data. To show a bit what is possible with such a One Data solution, we have done during the prototype phase, we have done numerous tests. And I think half of these tests were about the functionality and the performance of this data management solution. as we are really going into new, I think, levels of overall data performance and scalability. We knew at the beginning of the project very well what is possible with one server and one disk and one container and one disk. But what was important for us was to know what happens when you start thousands of containers, thousands of servers, and the data is spread over thousands of disks. And this is what we have done here. We took really the CERN CMS experiment as one of the best examples of a large, very large data management processing, and run part of the CMS jobs in total here with this slide. You will see it's 200 jobs that were run by 200 clients, and probably the figures are not readable from the distance, but we achieve here an overall I/O performance, data throughput of 3 gigabytes per second. And it is very stable, as you can see from the graphs. So the graphs show the accumulated data performance of all the jobs, all the clients. And if you do that for a while, the interesting thing is that you see that you can process really by scaling up the numbers of containers. In this case, you can process tremendous amounts of data in a relatively short time. So here we processed 100 terabytes of data in 9.5 hours, which shows in summary we did have this 3 gigabytes per second over that full period. So thanks to CipherNet for giving us these figures. So very impressive, and I think this is what we hope will advance science or accelerate science in several areas, maybe looking at data sets and analyzing them that has not been possible before, because we can simply scale the way it is being done. So coming to phase 3, of course we first we'll have a phase where we are going to again develop further functionalities and test evaluate them, but the difference is that already on day 1, actually right now we are starting again with various scenarios with using the hybrid cloud, and that can be seen from the next slide. So basically from this week we have already started again with new workloads, new applications, new tests, and are using about 5,000 CPUs in total, and this will scale up. This will scale up during the phase 3 up till the end to about 15,000 CPUs, since we as T-Systems will provide 10,000 for the contract that we run, and 5,000 also for the second pilot that we support as a subcontractor. The same for storage. Also here you can see a significant ramp up towards the end of phase 3, and that is, I think, where we will see some very interesting learnings similar to the phase 2 testing that we did, where a lot of the interesting results came at the end of the phase. So coming to commercialization, I think that is a big task for the phase 3. Now that we have come so far, now that we understand, I think, this tremendous capability of a hybrid cloud much better, we are also now in a phase where I would like to share with you 3 dimensions, what was important for us. So one is, of course, services. Yeah, we do already have since many years, of course, cloud services in T-Systems in various flavors. Open Telecom Cloud that we use here is a relatively new service, only 2 years old, based on OpenStack, so a very open source philosophy behind. But important for us is that we extend these services. And you can see here from this catalog, this is our service catalog as it is today. The white areas were there from the beginning. The others are the ones that we have already, say, enhanced or introduced during those last 2 years. as new modules, as extended modules, and some of them were really directly influenced by Helix Nebula. As an example, the federation functionality that we have now with the OpenStack Cloud to connect really seamlessly identity management systems between user organizations and our cloud. That was a direct effect of that. And also what I mentioned, the compute flavors that we offer, the HPC or high performance flavors as we call it, that has been extended from where we started 2 years ago, now to offer a much broader range of machines, going up to 64 CPUs and more, that you can also use in clusters, typically like in science is used. We have other functionalities. I cannot go too much in detail, of course, but maybe nice to mention is also tech management. What is behind this? One of the elements in the phase 3 will be also to do cost analysis, total cost analysis, to really see what scenario not only is technically viable, but at the end, of course, also sustainable for a user organization. And tech management is a very important functionality that helps us to track every single resource that is used in a cloud to a certain project or to a certain use case, so we can really have a very transparent cost idea. What does it cost in the end to produce a certain result on the cloud or somewhere else? So that was the one dimension, services. So here we see a lot of evolution and things that we have used. But another very important dimension is if other users will also believe that they can use this in their environments. And that is not only science, that might also be industry, that might also be things like healthcare, where, of course, data can be sensitive. So another very important dimension that we support and continuously extend also with the knowledge now of the Helix Nebula project is security. So really to provide users the trust and the confirmation that, yes, not only we do care and we have implemented a lot of processes to manage the security in our infrastructure exactly according to best practices, but that it's also certified, certified by external parties. And especially I think during phase 3 very relevant, the EU GDPR, the data protection regulation, will come into effect in May in 2018. And here also I can say that T-Systems already achieved a certification in Germany that basically includes all the EU GDPR aspects, so that we can really here say it is safe to go and continue on this way and use the infrastructure as if it would be your own. The third dimension, what I wanted to share is the market. Of course, we are in science, and that is very, very interesting, very, very challenging. But there are also areas where it's a combination of science and business which makes it very interesting. And this is a very nice example, is the Copernicus program, also a major infrastructure of the European Union to provide environment data, land data, water, atmosphere data to the industry, to decision makers in public authorities. And this data, for a large part, is derived from space sensors, from satellites that have become very important data for predicting, for simulations, for analyzing. And we are have just been selected by the EU to provide all this space data now on a cloud platform to be used by industry, by public authorities in a way that has not been possible before, simply by using the data, not having to download it, not having to store it, but simply go to the cloud, analyze the data with your own software or with a pre-configured software and get the information. Just to concentrate on this effect, what is really embedded in this data and how can we use it better. So that's why we say exploitation, especially of this space data, which has become crucial. I think all of you that have seen the pictures from space down to Earth know what is there. It is very beautiful, but also very, very important, I think, today to analyze it, what is happening down on Earth. So this is a project that we, as I said, have just been awarded to start. The services will start in the next months, run by Atos, and T-Systems will provide the hybrid cloud, which also takes a lot of the learnings from the Helix Nebula project. So coming to the last part, so challenges. What do we see now going into the phase 3, which will run up to the end of the year? The key things to focus at. So one, I think we have already seen during the phase 2 testing, it is a challenge to look in all those different use cases, even when it's within physics. We know that physicists look at very different things. To get the best performance out, we feel that we need to understand it, so that has taken us a good deal of the time. And also during the phase 3, I think we even want to extend the number of users. For us, very important that we understand that we have this communication to really get the best out of each case and make it run in the best way, even maybe fully automated, as we have seen from the CERN CMS use case that was run by the INFN Institute here in Italy. The second challenge, we know that there is a lot of data in science available, but not always used to the maximum, especially outside of the own institutes, the own organizations. So integrating the data that is there in the institutes within the one data system, what was identified during testing as a challenge, that will be a key focus of phase 3. We know it's possible. We have seen how it is possible. We really want to show that now with some very good use cases, how other users can benefit from this functionality. And the third and last, but certainly one of the absolute key aspects, what we believe, as has been mentioned by Bob, of course, service payment. At the end of the day, every solution we say is as good as what you pay for it. So it must be customized, it must be fit to science, and especially how procurement of infrastructures is being done in science, or like in EU, in other authorities. So here also the new functionality that we will bring to our hybrid cloud solution with service payments will be a key focus to get that in the phase 3 in a new dimension with new capabilities that may attract, and I hope, many new adopters and come also to use Helix Nebula as a platform. So thank you very much for this opportunity.
So thank you very much, Yuri, and once again, congratulations to T-Systems and the rest of the consortium for being the first announced pilot phase winner. Also, Yuri highlighted that the results of the developments, innovation performed inside the context of the Helix Nebula PCP are already being exploited and commercialized through T-Systems' own service catalog, and also for the work through the Copernicus data infrastructure and data information and access systems. Okay, now we come to the second winner of the pilot phase awards. As you know, in Helix Nebula, in the pilot phase, we don't end up with a single winner, but there are multiple winners. And I'm pleased to say that the second winner in this contract phase is the RIA Group. And I'm pleased to announce here we have Alistair Pigeon from RIA to come and receive his award.
So, while Bob's setting up the presentation, we too are very pleased to be part of this phase of the Helix Nebula Science Cloud. It's been quite a tough competition. It's been a lot of work over the last year or so for all the consortia. And so I extend our thanks to the buyers group for selecting us for this pilot phase. Nicely, Yuri has explained quite a lot about One Data, so I don't have to cover that again. So our approach, our vision for this is slightly different. Instead of just having one cloud provider, our approach is to have a multi-cloud solution. We believe that is beneficial for a number of reasons. First of all, it allows us to offer a hybrid cloud system at scale. In the phase 3, ultimately, we'll have to provide 10,000 cores and 1 petabyte of storage. But the original buyers group objective was more than 400,000 cores and more than 100 petabytes of storage. So although this seems a lot in phase 3, but it's still only a few % of the eventual demand. So the design has to scale for that demand. The multi-cloud approach can also deliver that in a cost-effective manner, because you've got a choice of different clouds, and it gives you obviously diversity of clouds and diversity of choice, not just from price, but each cloud provider has a different offering, and each cloud provider may meet your needs, whereas another cloud provider might not. It's built on a pure IaaS approach, so to ensure there's no lock-in, to take advantage as far as possible is market pricing, and that's not always possible in the public procurement approach. And importantly, with minimum intrusion into the buyer's own infrastructure. So in line with the buyers group objectives, this has been to try to lay the grounds for the future European Open Science Cloud. So Res, the prime contractor, we're leading, in our team we've got T-Systems, who you've just heard about, a very strong cloud provider, Exascale, who are based in Switzerland and now Austria and Germany, and they worked with us in phase 2. We've now got Advania for phase 3 as a third cloud provider. They're based in Sweden, but they're providing data centers in Iceland, and they're specializing in high-performance computing for us. 6 Squared are providing the Nebula platform, which is providing the overall multi-cloud management and deployment technology to automate activities as far as possible. And as you heard earlier, Cyphernet are also providing the One Data solution for data management in our consortium. The important thing is that we're working together. We're starting from a production service, which is Nebula, and during phase 1, 2, and now 3, the whole idea is we're innovating, we're then demonstrating, we're getting feedback from the buyers group, and we're learning ourselves sometimes, and then we're feeding back that into the innovation. The Nebula approach is every 2 weeks we make a new release so we can rapidly innovate the solution to adopt in an agile manner. We're obviously building on 3 established market-leading European cloud services. You can enhance your own community or private cloud to extend that with commercial cloud services. And you can create cloud-native applications to run on each individual cloud, or you can use the Nebula service to deploy your application to any of those clouds, and you have the choice depending on what you want to do. So the strapline for our solution is any app to any cloud. Some of the challenges overall are obviously to deliver the throughput from the Home Institute to the cloud, and also from the data source to the virtual machines. We also, to provide a true hybrid cloud, have to integrate the buyers group clouds, and we demonstrated in phase 2 the integration of the embassy cloud from EBL and MBL, and also clearly there's all the EGI federation that could be integrated as well. As Yuri mentioned, there are a wide range of applications and use cases from the buyers group, even though it's just generally in the physics domain and microbiology domain. So we have to support all those without preference to one or the other. Containers are increasingly popular, and we're supporting container deployment and container management solutions. So that's has been part of the phase 2 activities. And the single sign-on is required to provide seamless access and security for the users to all the different clouds. And again, it's to try to offer that with a minimum complexity and intrusion into the buyer's clouds. So we've got a number of complementary partners in the diagram here. With Nebula, we have is the overall cloud management platform. People access the overall services via Nebula, via the single sign-on. They can either use Nebula directly to deploy applications to the different clouds, or using the tokens obtained from the single sign-on can actually access the different services underlying, and of course there's one that includes one data, providing the data management solution. The aim is to support all sorts of different connection means, to provide overall reporting, accounting and management, and that's all done at the Nebula level. We can also perform service level agreement monitoring to ensure that the service levels offered by the different clouds are being met. And the single sign-on supports Edugain and Elixir. We're following the Shell and Data Protection Code of Conduct, and we provide browser, command line and API access. The command line and API access is very important because it allows people to automate their activities much more than having to go through a browser interface every time. And then finally, the unified data management I mentioned. So the three cloud providers, we have Exascale, who have an Apache Cloud Stack interface, Open Telecom, who also have an OpenStack interface, and finally we've got Avanya, again another OpenStack interface specialising in the HPC, and then again CipherNet for the data management solution. HPC as a service is an important feature of the HNSci Cloud, providing very large virtual machines, and we're able to cluster some of those machines into so-called super VMs, up to more than 256 virtual CPUs and more than 1 terabyte of RAM in a cluster. Each of the cloud providers provide different HPC capabilities, and it's up to you, the users, to choose which ones they would like to use. Most of them support the InfiniBand access, and Exascale and T-Systems also provide GPU access, and of course they're all accessible via Shell. So the Nebula platform gives us our multi-cloud and hybrid cloud management layer. So it gives you, the users, the choice of the cloud based on price. So that's in the context of phase 3, that will be 3 different clouds that we're supporting. So you can choose based on the price, performance or service guarantees without the vendor lock-in. So you can move your application to another cloud. That's even easier obviously if you use the Slipstream platform to do it. We're supporting advanced quota management over multi-tenant user organization with subtenants as well. Transparent interoperability between your own community or private cloud and the commercial clouds. We've also got fast deployment of new features through this rapid innovation cycle I mentioned earlier. And optionally, as I said, you can also automate the deployment of applications to the different clouds, making use of Slipstream, which is part of the Nebula platform, to minimize your cost and hopefully maximize the performance. There's also an app store where there are curated applications, and users can put their own applications into their own app store, which they can then deploy to the cloud of their choice. So obviously we have to support large data sets. This is largely done through object stores, supporting through One Data, supporting both POSIX and object store interfaces. The key point here in phase 3 is supporting the GDPR compliance and the ISO 27000 series security. Well, there's another slide on that in a minute. Clearly, the efficient data access relies on fast networking. The requirement for phase 3 is overall to provide, is to provide 40 gigabits per second. T-Systems alone are providing 2 times 20 gigabits per second. Exascale from 3 different data centers can offer 20, 10, and 10, depending on which data center it is. Advania, although they're going to provide only about 10% of the overall capacity, will also be connected with 10 gigabit per second, so that's the minimum any of the data centers support. So on aggregate, with all the data centers available that were likely to be used, we've got certainly more than 40 gigabits per second. So one way to help reduce complexity and overheads is to support containers. Some of these container management solutions are actually already supported in the App Store, so people can take them off the shelf, if you like, and use them to deploy their applications onto the different clouds. We can provide other tools possible, such as schedulers and other things, but obviously that requires input from users on what is wanted there. So security in phase 3 is important. Part of that is analysing security. As T-Systems indicated, they're already ISO 27000 compliant, as are other cloud providers. But the key thing is to ensure the whole system is secure. So part of what we will be doing in phase 3 is analysing the Nebula and One Data elements to make sure that they are secure through a risk analysis and so on. The business model and commercialization. I mean, we have a track record, particularly through Slipstream and Nebula, as taking R&D developments and commercializing those. We're trying to offer the widest cloud choices within the constraints of the PCP. So, as I said, we've now got 3 cloud vendors, with the aim to avoid vendor lock-in, but also just to give the users that choice. Some of the lessons from the Helix Nebula marketplace and also from phase 2 is that public procurement models aren't always ideally suited to this sort of procurement to get the flexibility and the full benefits from the cloud, and I suspect that may be part of your discussion this morning. But so there are some things that can be done with some planning and forethought, but it's clear that to get the best discounts and lowest prices from cloud providers, they need to have some upfront commitment, which could be through reserved instances or upfront payments, because that way they know that they can reserve capacity and you'll get significant discounts for that. We also have the concept of bring your own contract. So if you have a contract with another cloud provider, you can come along with that. We can integrate that cloud provider into the platform, and you can then manage that cloud provider via our platform, but still have your own contract directly with that cloud provider. We're also, a number of managed services can be offered on top. Yes, people can use One Data out of the box, or a Slurm batch cluster, a Docker Swarm, Kubernetes, and so on. But you're on your own. So managed services, we help you do that. We run that for you, and if there are problems, we sort it out. So it's another way of working. We have to find out from you whether that's of interest to you. Of course, there is will be a fee associated with it, so are you ready to pay? So, these are some of the key questions on this whole HNSI cloud, is how the commercial model is going to work in the interests of both the buyers and the providers. Obviously, if there are some early adopters who would be interested in using our solution during phase 3, we'd be pleased to talk to you about it. So going forward, obviously phase 3 is scaling up what we've been doing in phase 2. It's focusing more on security, sorting out or demonstrating the performance of the whole data management solution, also just demonstrating that we can sort many users in the system. So our solution is bringing together a number of existing products and services, which we've developed further as part of this activity to scale up and meet the needs of the science community. As far as possible, where it's provided as a service, and obviously, as I mentioned, managed services are an option too. We are relatively small, led by relatively small companies with rare leading it, but obviously we've got big companies like T-Systems supporting us, providing the cloud. And we think it's a good foundation and open foundation for the European Open Science Cloud in the future, which will include at some level commercial cloud services. So thank you very much.
Thanks, Alistair. So thanks again to Alistair from RIA Systems. So you've seen now the presentations from both of the winners for the pilot phase, highlighting the services that they've developed during this process to get to the pilot phase, and also highlighting as well, if you noticed, that the commercialization is already underway for most of these developments, and that the majority of the developments are made in an open source manner, so that the results can be deployed in this hybrid model without the use of licenses in the host organizations. Okay? So we've talked a lot about the pilot phase. Now it's time to ask Andrea Chieri from INFN, who will be leading the Procurers activities during this part of the pilot phase, to explain what's actually involved in it.
Can you hear me? Yes. Yeah. Okay. We are here today exactly for this reason. We are now starting the pilot phase, and the first work package that works on the pilot phase is the WP5 that I'm going to lead. The objectives of the pilot phase are exactly the one that you can see, that is assess each pilot, and assessing it, we will give input to the final reporting, and of course we will provide input for our contractors. And novelty compared to the prototype phase, that we will open the pilot to end users, and we will deploy their application. This is very important, and they will also provide us feedback in the final review. Finally, the pilot will provide the platform on which the final demo of the project will be performed. There are two major tasks in this work package that are the scalability and robustness test, the task 5.1. As the two contractors already said, the prototype will be expanded and become a real pilot, and we will focus our tests as a buyers group into scalability. Scalability is very important because we already assessed positively the functionality and the basic infrastructure that is working well for us, but now we need to move to a bigger scale. That is the scale that we expect to reach at the end of the project. And the second task is task 5.2, that is the pilot assessment, that is basically self-described. We will assess the pilots against the published criteria. More or less, I already said this, we are here now starting the work package 5, where we will begin testing the pilots with a larger scale, and we as a buyer group will execute a bigger test suite. I will describe it later. Also modified test suite compared to the prototype phase, with a new range of application workloads. The work plan for the first phase of the project, first of all, we We would like to achieve the 100% coverage of the tests that we weren't able to complete during the prototype phase due to some problems that we have. And also we would like to perform some of the tests that we have already done with Advania, that is provided by RIA. And after that, in April, we will have the first formal review. And it's very important, dear contractor, to stress the fact that there is still the possibility to terminate the work order if our tests show that insufficient progress has been made. In the second period of work package 5, that is April and May, the capacity of the pilot will be increased, and we will start for real testing scalability, security, and also reliability. And at this stage, a selected group of end users will be given access to the pilot. And at this stage, it is very important that we have some documentation and tutorials to give them in order to speed up their use of the two pilots. After that, in May 2018, WP5 completes, followed by the second review, that is MPIL 3.2. And in this stage, feedback from the end users will be absolutely taken into account. Here is a picture with the cloud service capacity that will be given. It is a combined capacity. So as you can see, now we are here, and we basically will be given 7,000 cores with 700 terabyte of disk storage. After the first review, we will begin the scalability testing, as I said, and we will be given 10,000 cores and 1 petabyte. And at this stage, a selected subset of end users will be given access. Here, the work package 5 ends, and after this, general availability to end users will be given. And we will reach 20,000 cores and 2 petabytes of storage. Here is just a short introduction to the test suite that will be given. So I will just give you a quick introduction to it. A later presentation will go more deeply into details. For CERN, we will have batch service extension, a new test that is the GPU with machine learning, Personar at 40 gigabits per second, virtual machine provisioning and personalization, security assessments that are very important at this stage, and the Dockerized deployment of EOS Sandbox and Swan. For CNRS, the dynamic expansion of the HT Condor cluster will be tested, and they will also introduce some LHC VO Monte Carlo. DAISY will have a very extended testing of HPC, photon science, and crystallography. EMBOL will do some marine metagenomics. ESFR will focus on functionality and the user-friendliness of cloud interface. ESFR already tested a lot of the HPC basic infrastructure, and now they are going to test exactly, as I said, when we will introduce the end users, they need to be able to immediately use the clouds. For EFI, Magic Hybrid Cloud and CTA Dirac data fetching, we, INFN, we will test Bell 2. In the previous phase, we used only simulation. Now we will introduce also production. For the DIM farm scale is our name for the dynamic expansion of the cluster. We will do it at a wider scale. And we will also test a solution for CMS expansion of the workloads through DODAS. That is their cloud-enabled solution. For KIT, we will have again a batch system extension. These apparently are the same name, but they underline have different batch systems, and so they have to be tested all, just to be sure they work exactly as expected. They will also perform CPU benchmarks and federated authentication. Last but not least, Sursara, BBMRI import and testing of images and recipes, LOFAR BBMRI data transfer, and LIGO Virgo. As for the work methodology, we will continue the good things that we have already done during the work package 4. That is mainly gathering in weekly telcos that last more or less 1 hour, followed by telcos with contractors the same day. We have a mailing list dedicated to work package 5, ticketing and logbook system that we introduced during the work package 4 will be used also during work package 5 that are provided by DESI. Collaborative tools provided by SER to share important documents and notes that we don't want to give to Google. And we will communicate with the contractor through their system, like ticketing and logbook. And this is it.
Thank you very much, Andrea.
Question?
So you highlighted all the extra work that remains to be done during this pilot phase. Also through the afternoon, we've spoken several times about the relevance of this work for the European Open Science Cloud. And it's an honor now to invite Silvana Masella, co-founder of Trust IT and chair of the European Open Science Cloud high-level expert group, to talk a bit about the European Open Science Cloud in practice.
Put that in here, I think. Okay. Thank you very much.
It's, no.
No?
This way.
That's lovely. Thanks, Andrea. Nice to meet you, by the way. I don't know. Thank you. Okay, thanks, Bob. So it's an honour to be here. I don't know if those of you who don't know me, I'm Silvana Masella, the founder of Trust IT and the CEO. Thank you very much, Bob. It's always great to collaborate with Bob on and we have you'll have met Sara Garavelli, who's a project manager at Trust, who is working on the activities for H&S Science Cloud. So I'm sensitive to time. Why am I here? Bob said that it might be nice to give an overview of how the EOSC is going to proceed in an implementation perspective, if you like. So the title of the presentation is called Prompting an EOSC in Practice. You are, I'm sure, familiar with the first HLEG of EOSC, which was chaired by Baron Mons, who produced a high-level expert group report, which then supported a series of activities that went into the work programme in the past and delivered a set of concrete recommendations and priorities. These are the members of the actual second working group that was commissioned in July 2017 and runs through to the end of December 2018. What we're looking at is, in the second group, are basically three perspectives. We need to consider the staff working document that comes out of the European Commission, which first version, which is not public, should be available in May. And this is an ongoing activity that all the DGs, Dirk, correct me if I'm wrong, actually address. So it's not one particular, it's not just DG Connect or DG RTD, and they all have to have a consensus on what's written, on what the actual idea and interpretation of the implementation of an EOSC from a governance, policy, technical, architectural point of view, executive board. So everything comes into here. The group works to support that and brings out additional guidelines and support to this staff working document. You may remember a set of signatories came to the EOSC summit at the last June 2017, the EOSC declaration. This resulted in 70 signatories from different organisations. They called them also a coalition of doers, suggesting certain types of things they were going to do to help deploy an EOSC in the future. Now, what's happened to these reports? They're there and they need to be analysed clearly, which is a humongous job. People made the effort, all these organisations, to write these endorsements, and so the idea is to actually animate these signatories, get them back 1 year on, and invite them, and in fact I've already written the date, on the 13th or 14th of June 2018, to actually say, okay, so you agreed to this, now what's happening? And actually produce an EOSC story. And I'll give you an idea of what we mean by these EOSC stories, because people like to be listened to. If you're telling me to write an endorsement, you don't want to be forgotten, do you? And you want to then be able to stand and say, listen, this is what we're actually doing to take this forward. This also brings encouragement to member states when they see what's actually working within their countries. And the EOSC has also led to a series of activities. I know Davide is involved in this from an Italian point of view. The EOSC has made member states worry about what their storage, resources, compute network actually amounts to. Because up until now, I'm not saying this hasn't been the case, but it hasn't been assessed in a strategic way. So if member states all sit round a table discussing EOSC and wondering what part they're going to play in a governance model, they also need to have ready at hand the statistics and money and the finances of what goes out from their country in this area. Okay, so that's been a new concept for me, as I hadn't really appreciated that. Those of you in Italy know that this is a very fragmented, difficult system to get your Cinecas, CNRs, INFNs sitting round a table going, right, let's do the maths. What is it that we spend every year? And then the other part we need to concentrate for this particular group is to worry about new financing instruments for an EOSC business model, and some of you already have discussed these in some of your use cases for the rail group. I see that this is coming out. Clearly, this is an important feature, and this works also to worrying about what can be implemented as FP9 in future call proposals, rather than, we've seen under Horizon 2020, who's familiar with a cascading grant system, where a set of money, some of you, it's basically a set of money that's then given out to third parties. So money comes in and it just travels out in a particular way through open calls, through mini grants. And it's a very heavy administrative system, but works and keeps a lot of people happy, if you like. So a consideration for FP9 could be that some, it makes you very happy, Dirk, yeah? A consideration could be that some of the budget could be set aside in a European Commission funded project and put to pay for some vouchers or cloud coins, okay? So that's the idea. Then I'll give you an overview of what the TOC is looking like and the timeline as well. So, I've already said what it is the second group is doing. As we know, there's some of you in the room, there are ongoing parallel activities in addition to what the European Commission works on in the staff working document, like Open Air Advanced, EOSC Hub, the EOSC Pilot, which also bring out a set of results that help support a prompting an EOSC for the future. And then this, or there are, in addition to our group, there's another expert group called the Fair Data Group and the Open Science Policy Platform, which then responds to the European Commission timeline. So we're in February. We have a draft report to pull out by the end of March 2018. So I invite any of you who would like to support with some EOSC in practice stories already that we're going to put in as an annex. And I also already have an example I'm going to give before dropping off now, which is nice. why are we doing these stories? Because if we can show something tangible on how an EOSC could look like, it makes everyone feel a whole lot better. So I mentioned the staff working document. The report goes in, then what happens? We request and send out support to the signatories to come back and meet in June to this summit. There are back-to-back meetings. The endorsements are elaborated further, and we then help whatever's in these in practice stories from these other endorsers to then help feed into the final report, which will be the final recommendations that will support the implementation structure of the EOSC in practice at the end of 2018. An idea for the final report is that we pull out also some ideas for FP9 and some new topics for discussion. So, I'm not going to go into the detail of what the EOSC is. Many people are still saying today, oh, EOSC is just a service cloud though, isn't it? And, or is it a portal? Well, is it just one and it's not my infrastructure, it's yours? It's everything. It's so the term perhaps a common gateway, maybe it's that impression better, that covers resources, cloud, access to content, compute, people, training. So I think this does manage to cover the sphere of everything, with its main goal to federate existing initiatives within a single, consolidated, seamless gateway. And then, I won't read all the points, but it's here to help define and implement incentives to drive researchers to publish, curate, certify, store, and reuse data along a series of different disciplines, because it has to be interdisciplinary first and foremost. So, going back to the point around financial instruments and a business model, in the EOSC in practice template, there's an element we've called the sustainability model. Now, some of these points that are listed here are due to a pilot study that many of you might be familiar with, that's ongoing. It finishes at the end of 2018 with the National Health Institute in the US, where biomedical research data was accessed through a different set of service providers. And this pilot case came up where there were different investigators who could access through a series of cloud coins this particular model. Now, in the report, we would need to list a series of recommendations, but we cannot afford, what we don't want to do is be prescriptive and say, this is what it's going to be like, everyone, so take it or leave it, because it clearly cannot be that model. What we do need to do is to incorporate this as part of the governance model, an evaluation criteria for selection needs to be introduced, which also needs to be part of the governance model, because we're suggesting that we could allow international, national and private funding entities to maintain key electronic resources for the benefit of the scientific community in a federated environment as a decentralized business model to support everything else. And so the level, all of this in defining the evaluation criteria of who does what is important. Then we build the business model, and then we list a series of different financing instruments. And then with that, the community can then go away and select what it can do best. But it's really a hybrid business model is the consideration here, which would be perfect, because if you start talking about cloud coins that are functionally denominated euros, the first question that comes to mind is, well, who actually is going to give me that money, okay? And then we go back to the governance model, to the whole, well, you know, which, with the member state discussion in terms of their financing and how much they want to put into the pie. But if you consider that there's a hybrid model where some of the grant could be allocated, and it starts making sense. I know already within the H&S Science Cloud, the concept of vouchers is being considered for 2018, so it's not an impossibility, and you're going to have a look at this clearly in a much more pragmatic scope. So we're here, this isn't going to go away, considering how financing models can work outside of the realm of a normal just budget coming in from the EU project only is important to evaluate. So, zooming in on the interim report, we look at the considerations of the staff working document, as I said. We tap into the recommendations from the first report. We want to be able to introduce a set of priorities, which I'm going to look at further on, with some recommendations. The part around the business models and financial instruments are key. Tapping into the aspect of fragmentation of data management. This came out in a meeting last week in Europe that Science Europe organised with I don't know if some of you were there, but one of the key takeaways that there's a huge problem of fragmentation of data management, and how is this going to be resolved, and how can the EOSC consider that. And then we align with the recommendations of the FAIR Data Group and the OSSP, and then we want to put in a series of these EOSC stories. Now, in the face-to-face meetings we had, and I'll conclude very shortly, we came up with 8 main elements, we call them, this dimension of what are the basic features that people have challenges and problems with, that an EOSC needs to face. So, we're covering different research fields. There's recognition. Now, recognition here can also mean reputation. So how a data scientist is given recognition in the work he or she produces. And here we come back to another problem of data management. Because today what's happening, people who actually author the content also say that they're managing the data, which isn't the case. And so how do we differentiate and say, right, you've delivered the data, that's great, and I'm going to give you this recognition for it, but you do not manage your data, and that needs to be clearly articulated in your EOSC in practice story. The multiple member state collaboration, clearly in Europe this is always an issue, so if you're able to show that, it's an added plus. Your services are trusted. There's some form of certification, because this also helps deliver trust. We are all GDPR compliant. This is obviously a major issue for SMEs, me especially. You know, we're working very hard to ensure that all of our websites are GDPR compliant with a new checklist. I don't have someone who's an expert in my team on GDPR, and I don't really want to spend thousands on a lawyer to bring him or her in to give me this information. So I need to read up, and we need to be on the ball on this, which leads me to another feature about data management policy. I want to have a data management policy plan as a small SME. So that is also a feature that you could tag on to being not only GDPR compliant, but I can say I do things along the books for data management policies. Sustainability model, and then describing how your users are, how your users benefit. And with this, Bob kindly sent through the H&S Science Cloud EOSC in practice story, which responded to admirably on all the dimension sets here. What would be good, clearly, is for 2018 to zoom in more on the sustainability model and bring out exactly how you see that working as a model, okay? Also in terms of the vouchers, because that's what people want to read and people want advice on this for the future. Some thoughts for discussion going forward. Listed a series of top-level priorities for EOSC that we need to consider. that very much replicated in the 8 dimensions listed before. And then building upon the recommendations from the first HLG report, data skills and capacity building. Look at my problem as an SME. This is a serious problem I have today. Okay, so how do we make sure that we can construct some form of teaching that SMEs especially can have on tap? Interoperability of existing research infrastructures, and this should be perhaps part of the governance model, can help a more user-centered approach. And then the aspect around national funding streams. I put this because of the whole concept of what's happening in Italy. This needs to be clearly analysed against the background of different funding streams, so member states know what position they're playing within a governance model. With that clearer, everything becomes clearer. And I think that's it. Thank you very much.
Thanks very much, Silvana, and highlighting the important work that the high-level expert group that you're leading is doing to better define the future European Open Science Cloud, and highlighting how activities such as Helix Nebula Science Cloud could contribute to that and make the European Open Science Cloud a reality. We're going to terminate now with João Fernandes, the technical coordinator of Helix Nebula from CERN, to show you how we're working to expand the users group and look at the future.
Can you hear me? Okay. So I understand that I'm between you and the coffee break. There's also a picture to be taken, but bad news is that it's heavy rain outside, so bear with me 5 minutes. The presentation will be about basically how we are seeing this. The buyers group is seeing this from the WP5 to the end of the project. I'm very glad that I think we are on message with all the presentations that I saw here. So just recalling a bit where we are, so we come from a functional testing period. So we had 85% of the tests that have been deployed. We want now to deploy them there and finish them, having them successful deployed, but also go on scalability tests. And it was very nice to hear from Yuri the example that he gave from scalability, but here we want more than that. We need more than that. Okay. So that's one of the points that we need to touch here. It will be an important thing because data management, scalability, and single cloud versus multi-cloud solutions is here where we are going to understand what are the benefits from each, both technically and financially. Then we have, as Andrea said, the end user access that will start on the second phase from April at 5,000 cores and then 10,000 cores per provider. There, other things and new things, innovative things are going to end up there because we have GDPR, for instance. That is the first time that we are going to touch it during the project with the end user access. And we'll have number of workloads and applications that are going to be deployed in a staged way. So basically, this is what is going to happen from April to the end of the project. So if I can highlight a bit the 4 main points of this phase of the rest of the project. So end user access is one of the main ones because it's the first time that actually end users are going to be accessing the platforms. And again, things like GDPR, all the GDPR aspects need to be treated here. With WP6 and with EGI leading the WP6, we are going to have the first projected results of the project with some deliverables that are going to be fed in the EOSC roadmap, user feedback, and also all the lessons learned that we had up to now. And then there are 2 very nice and very important deliverables that I highlighted there that also bring some aspects about the innovation that we have been pursuing on the project. Is the total cost of ownership that we expect to map on the use cases that we are going to deploy during this phase. Probably we're going to select or pre-select a few use cases to map this total cost of ownership. the commercialization plans to exploit the results after the PCP. And I'm glad that Silvana was touching this before. Also, probe and assess the service voucher schemes and mechanisms that we can have for the future, that will be important for the EOSC. So the second aspect that I want to touch is this growing the buyers group, or the early adopter scheme. So as you know, during the project, we have been deploying and developing the concept of the early adopters. Basically, we want more organizations to benefit from results without being compulsory beneficiaries of the project. So we have a document that is explaining all that. Basically, and if I can resume the 4 aspects of the early adopter scheme. So adopter will sign a direct contract with provider, so all the money flows will go between provider and early adopter. The services are not R&D anymore, will be the resulting services from the R&D of HN SciCloud. So everything will be commodity. And there are no additional requirements for the services. This should be compliant, and it will be compliant with the HN SciCloud Cloud Services Agreement, but completely outside of the scope of the consortium agreement and not all the other founding documents of the project. And then by default, we are going to ask for the adopters to share their experiences in order to get feedback and again build on the feedback that these early adopters will bring in. I will finish with this slide. See how fast I was fast. We have a pile of events that are being organized. Those are the dates that you see there. Not all of them will have demos, use cases, and training, but some of them we are mapping this. Some of them are the reviews of the project. So this is ongoing, an ongoing discussion. I just put the dates there so you can start to take notes to see where they are going to take place. Okay, I almost finished. So we have another small surprise. I'll just ask Sarah to come. And I ask, yeah. So do you want to say a word about what you're going to show so they know? Or it's a full surprise.
So we have just released a new video. Just a second. That promotes the use cases of HN Science Cloud and also
an expression of interest to the email appearing on the screen. Okay. Needs of the high energy physics.
Okay.
We manage. Okay, so basically the video announced the launch also of the early adopters group.
HN SciCloud in practice, meeting the growing needs of the high energy physics, life science and astronomy communities. What do research organisations operating in the high energy physics, life science and astronomy domains have in common? A mutual need to increase the capability and capacity for analysis offered to their users to keep pace with the growing amount of scientific data collected. The HN SciCloud hybrid cloud platform is able to respond to these requirements. The platform combines services at the infrastructure as a service level, including compute and storage, network connectivity, federated identity management, and service payment models, to provide an environment supporting the entire life cycle of science workflows. In 2018, the capacity procured from the commercial cloud service providers in HN SciCloud will exceed 20,000 cores and 2 petabytes of storage, with a network bandwidth of 40 gigabits per second. This huge dimension of resources will support a broad set of scientific use cases aimed at testing the scalability and reliability of the platform. The first use case is the WLCG project, a global collaboration supporting the experiments at CERN's Large Hadron Collider. It combines more than 170 computing centres in 42 countries with grid infrastructures, stretching the capabilities of the HN SciCloud platform to process physics data. The second use case is the pan-cancer analysis of the whole genomes project. This project coordinates the analysis of over 2,000 whole cancer genomes. Its approach is based on genome beyond gene-focused studies and entails analysis of large amounts of data. Finally, astronomy is also in scope. The huge amount of data generated by the SKA Pathfinder LOFAR telescope will feed the HN SciCloud platform to better understand the benefits of adoption. Not part of any of these communities? No matter, HN SciCloud has launched its early adopters group for research organisations wishing to become procurers of the HN SciCloud services and benefit from the advantages of joint procurement. Join now by sending an expression of interest to the email appearing on the screen.
Okay, thanks very much. That ends this webcast, and there will be further webcasts in the future corresponding to the series of events.
Let's suppose that you're writing a really important email to a caller.
And we will contact you by email. Thank you very much.